In this example, we'll look at using the TI-84 calculator to find exponential regression. Here's an example. The number of new cryptocurrencies Y changes day to day, but the approximate number of such currencies in circulation for selected years is given in the table. Year 0 represents the year 2015. So that's always important to note because that will help you adjust what you're plugging in if you are trying to predict for a particular year. So like if I was trying to make a prediction for 2018, I would use an x equals 3 because you're going to count the number of years since 2015. So the first part of the problem says graph the data on a graphing device. So I'll pull up my TI-84. To put in the data, I want to go to the stat key, select edit, and I have previous data from another problem. So I highlight my list and hit clear and then enter. I'll highlight list 1 and hit clear, enter. And now I can go ahead and put in my data. So my X values are 0, 1, 2, 3, 4, and 5. And my Y values are 491, 551, 617, 1,334, 2,995, and 5,392. So I've got my data into list 1 and list 2. You always want to double check to make sure you've typed everything in correctly. And now I'll go back to my home screen. So I'm not trying to get the equation yet. I'm trying to graph the data. So I'll go ahead and go to my stat plot. So I'll go second and then Y equals. I already have my plot on. If you did not have your plot on, you would hit enter and make sure that on is highlighted and hit enter. To get a good window, I want to first make sure that there are no functions in my Y equals. So I go to Y equals, that's all cleared out, so I'm good. To get a good window, I'm going to go to zoom and then zoom stat number 9. So I've got this great little graph here, and we want to know based on the shape of the graph, which function type would provide the best fit. So coming over here, I look at the shape of my graph, starts low, kind of flat and low, and then goes high very quickly. That would be an exponential function. So based on the shape of the graph, I would answer that an exponential function would be the best fit. All right, so now we want to find the model. So instead of just doing the graph, now I'm going to try to find the equation. So use a graphing utility to find a model of the form f of x equals ab to the x, and round a to the nearest whole unit and b to 3 decimal places. So what I'm going to do is I will go to the calculator and I'll go back to my home screen by doing second mode. I'm going to go into my stat menu again, but I'll go over to calc. And because I'm doing exponential regression, I want to scroll down to 0 where it says EXPREG. So that's exponential regression. So we're looking at 0, which is EXPREG. So I'll select that. I have list 1 and list 2. I go ahead and calculate, and that would give me my exponential regression. Notice it's in the form y equals a times b to the x, and it gives you the a number and the b number. So I would have f of x equals, and they say round a to the nearest whole unit. So I would have 346. The number after the decimal, directly after the decimal, is a 3, so I do not round up. I leave it as 346. So I would have 346. It says round B to 3 decimal places. So I'll look here, I have 1.664. So I'd have 346 parentheses 1.664, and x is my exponent. So there's my first answer. And now they say write f of x as an exponential function of the form f of x equals a times e to the bx. Now, since e to the x and natural log of x are inverses, remember we learned they're inverse functions, we know that e to the natural log of x is equal to x. So if I want to change the 1.664 into an e to a power, then what I would do is I would say 1.664 is equal to e to the natural log of 1.664. So I'm going to replace the base of 1.664 with e to the natural log of 1.664. And I just have to go ahead and calculate natural log. So I'll do ln of 1.664. And I'll go ahead and round to 3 decimal places. So 0.509. So that would be e to the 0.509. E to the 0.509. And so my second answer is going to be f of x equals 346. That part has not changed. And then I'll have e to the 0.509x. Notice the x still has to be up there in the exponent, but instead of the 1.664, I have e to the 0.509. So the new b value in the a times e to the bx, that value is always going to be natural log of your original b. So I can go ahead and write that. So this value right here, that will be natural log of the original b. All right, so I've got my exponential function in the a times b to the x form, and in my a times e to the bx form. And now I'm going to answer some questions. Use a graphing utility to graph the function and the data points. So I know my function is y equals 346 times 1.664 to the x power. So I'll go ahead and type that into my y equals menu. I've already looked at the scatter plot, so I should have a good window. Go ahead and hit graph, and you'll get a nice graph overlaid on top of your scatter plot. Now use either model to approximate the number of cryptocurrencies in year 6. So that means that x is 6, and it says round to the nearest whole unit. So I'm going to have f of 6 equals 346 times 1.664 to the 6th power. And now you just have to put that in your calculator. So go back to your home screen, do second mode, and you'll do 346 times 1.664 to the 6th power. And it says round to the nearest whole unit. So I have 7,345. The number directly after the decimal is a 0, so I do not need to round up. So 7,345. So that would be the number of cryptocurrencies in year 6. So the big takeaway here is make sure that when you are switching from the a times b to the x mode to a times e to the bx, that new exponent, the b value of that new exponent, will be the natural log of your original b value, your original base. Other than that, it's very similar to all the other regression problems. We're just using the exponential regression, which is number 0 in your stat calculation menu.